Hello, everyone. Hello, Piotr. Thank you that you find some time to for this presentation this evening. So let's get started. Uh, First of all, we want to say thank you to our general partner, it's Ukrainian Armed Forces. Probably the main reason why we still able to organize such events. Speaking about that, at the beginning of this year, we started our cooperation with uh, Help a Hero, Ukrainian charity organization, which helps our defenders with some equipment. For this reason, we created Friendly Jar to help them collect some resources. Uh, if it's completely optional, if it works for you, you can scan this QR code and donate any amount that works for you. Also, if you don't want to do it or have no resources for that, it's completely fine as well if you didn't. One thing to mention that if you donate 200 or more, at the end of this year, you will take a chance to participate in raffle from Help Hero, and you probably can receive some cute present for them. Also, we want to say thank you to all of you because you are the main reason to make this counter bigger and bigger every time. So really appreciate your presence here. Special thank you to our organizers team and join us in our social medias. Wish you a good talk, and Piotr, stage is yours.
Thank you and good evening. And I'd like to, continue this thank you if you don't mind. So I'd like to thank all the organizers for, keeping CoffeeJug alive despite everything, despite 4 years of struggle. Thank you, Alexi. Thank you to Ihor, right? Ihor is in a backstage, and all the lovely people who keep CoffeeJug running. Yes, let's go to today's or tonight's presentation, shall I say. I work as senior developer advocate for a company called Elastic, right? This is me, if you fancy to follow me in some social media. And this is how the AI sees me, because this talk is somehow about related to AI. So as you can see, I'm into community engagement. I hope I'm pretty authentic, and I'm mostly Java, which makes me ask you a question. And this is there's going to be a few questions, right? And please ask them in the chat. Please don't cheat, right? So the first question is, what programming language will I be using to show you some demos tonight? Okay, this is the first question. Yep. And also, you can let us know who you are, where you're from, what programming language you use. That's the question number 2. I'm broadcasting this from Poland. Yep. And little warning, because this is AI. With AI, and we saw it everywhere, including stock markets. Things can go up and down and change and everything. So maybe if you're watching this as a YouTube recording, don't forget to subscribe. Then of course things might have changed even in 2 weeks or something. So let's get to the actual meat, right? Some time ago, I was preparing a talk about stream gatherers in Java. There is this new concept, right? We'll get to what that is. Actually, this will be the theme of today's presentation: the stream gatherers in Java, the new addition, new piece of API in Java 24, and this screenshot I have taken with. I believe that was ChatGPT 3.5, so it's pretty old, right? Oh, we have people from Java, Go, Node, Python, Rust, a plethora of languages. I love it. Great. So back to the issue, right? So I asked this, and it started, it is telling something about collectors and gathering techniques and so on. And of course, this is not what I'm asking about, right? Because we all know collectors, from Java 8, and then there were some additions, but this is not what we are really looking for, right? This, at least not this time. So this is not really the stream.gather method or API. And here's the problem with AI, basically, in many cases. that what happens during training versus the actual use case, it's not exactly the same, right? Sometimes things are basically different. So we may train for one thing, or the model can be trained on some data, and then in production or later, it's basically not there. So now this is a later screenshot, right, taken like a year ago or something. And as you can see, it's still not okay, right? Because I asked about, like, specifically about stream gatherers, and the answer I got is still about collectors. And this is because, you know, in English, to collect and to gather are semantically close, and at least when it comes to Polish, they can be translated to even a single word, right? However, there is this other screenshot, and here, if you take a closer look, I hope this zoom works and doesn't crash anything. Yeah, you can see there is this gather, right, with the type arguments and so on. So this is the correct answer. Right, this time AI answered correctly. Yeah, it was introduced in Java 22 as a preview feature and so on. This is like intermediate operation that gives us flexibility. So we have just more than map and filter and so on and so on. Right, and it truly has this pieces as a initializer, integrator, combiner, and there's one more. So the thing is, what's the difference between these two screenshots or these two answers given by the exact same model, exactly the same thing, right? See, I'll be like switching for a moment so you can ask yourself, right? But maybe you already got it, that the difference is here, right? Once I have the search enabled, back in the day, like we could like enable search, and here it was disabled. So with the ability to search for stuff, the AI was smart enough to actually, find the relevant data, use it, process it, and based on that, provide us a good answer. So in a way, I mean, what we see here is not exactly RAG, but what that tells you, like the basic principle behind RAG, like why it happened, why do we have this pattern, and so on and so on. So let me like introduce you to certain parts or concepts that combined together give us RAG, which stands for Retrieval-Augmented Generation, right? So we are about to generate something, but the process of generation will be augmented or enhanced or improved, right, by some data we retrieve before that. So that's the whole point, right? And eventually we want to have the right answer, right? Maybe not the answer to everything, like 42, but at least the right answer to our question. So how does this happen, right? We ask generative AI or LLM, we pass it a question and we hope to get the right answer. And as you are able to see in some of these screenshots I have shown, that's not always the case. Because why? Why? Because it was trained on the data that was publicly available at the time it was trained. So when these models were trained, in the JEPs or in the blueprints or documentation, generally in the internet, there was nothing about stream gatherers in Java because they were trained before Java 22 happened. So there was not even a preview JEP. That's why it didn't know anything. And here's the same thing. For example, you work for a company, and let's say when a child is born, right, you become a mother or father, then you are granted, for example, some extra holiday, extra 3 days. And then, like, you work for company, like big one, little one, but it has its own policy. And how on earth should any LLM or ChatGPT or whatever agent we ask know what's your current PTO policy at the company you work for? It's impossible, right? So the whole idea is, like, let's imagine this holiday policy is like a book, right? So just to find, get this book, find the relevant page, sort of like get only this page, like we don't destroy the book because it's a virtual one, right? And we pass this single page to LLM, to AI model, and it's intelligent enough to read this extra piece of data, right? This extra context, and then reason, so this company, this person works for, they have this and that policy for extra days when they have a new child, for example, right? The thing is, how do we get there? right? Because this is the business data we have. This is the book, right? Let's say it can be like a wiki page, right, somewhere, or it could be like whatever basically you have, like some intranet portal, whatever. So the question is how to get this data to here to get the right answer, because this data, your business data, for example, your private stuff, is not part of this public internet data or the data this model was trained on. That's the whole point. And of course, like if you're like super rich, or I don't know, you want to waste money and generate more CO2 or whatever, then of course you can in theory retrain your model like frequently, but that's not cheap. That's not exactly cheap. That's quite expensive, right? So the thing is, like, let's find this from this business data, the stuff that we need, and then combined to like, or relative to our question, right, which we will use to find this data, we take this together, our question and the context window, and we pass it to the LLM, and then we get the right answer. So these are basically the steps of RAG. And I hope that the broadcasting software is working okay, and that you can see that it has animated arrows, and this makes all architects super happy, because there's not only plenty of arrows, but they're also animated. So they're like, oh, this is heaven. Anyway, let's go through these steps, right? I have shown you some. I will show you, sorry, some code. And you've like I don't know if these were the guesses. No, it was like the languages you use, but nobody so far has listed Bash. And I'm sorry if I'm disappointing some of you, because this is CoffeeJug, right? And I'll be using Bash today, but there is a reason for this. So what you see here is a simple Bash script, right? And I have here Olama running, so I'm running stuff like locally, using unpaid staff and so on, just to show you that it's possible. So what I'm going to do, I'm just sending a little serial query, right, a request, sorry, a little HTTP request using serial, let's be precise. And this is the Olama URL, which is my local host. And then I'm hitting this API, and this is my my payload, right? So this is the model, and I'm prompting it, what are stream galleries in Java? And apart from selecting model and prompt, I can also toss some options here. I mean, I'm doing this just for the sake of presentation. Here I'm doing this, I'm using temperature. And temperature, I mean, don't quote me on this, but what temperature could be meaning is it's like this YOLO factor, basically. So if we set it to 0, that is like, please don't be like that much generative. Please use the be factual and so on. Whereas if we bump it to 1.0, that means like YOLO, basically, like, generate cats and images or whatever, like be super creative. I think it's 0.6 a moderate temperature is okay for this very demo. So let me run this. Let me run this script that should be called generate 0, generate 0, and what we see here. I hope it works. Yes, it does. Let me make it a little bit bigger. See, it's oops, it was too much. It's just a streaming answer. So what we see here is basically, a stream of chunks that get back to us, right? Like pieces. That may be difficult to read. So let me stop it and let me just use this little stream printer, so it's easier to read or to reason about. And now you'll see, and this looks familiar, right? This is what we see in browsers. So see, this is what they're actually doing. And as we can see, this is the problem with like using only public data. That these stream galleries in Java, like part of Stream API from Java 9, and we obviously know that this is not true. And we like collectors to list. This is not what we asked for, right? And the model doesn't know. It doesn't know. Right? They don't know what they don't know. Therefore, it's trying to make up like the answer that makes some sense. So let's stop here as well. So the thing is, how can we pass some data to the model so the model knows what it's doing? Right. So let me open another file, and this is called generate like one, but that doesn't matter. This time, what we see is the same prompt, and only I will have like combined prompt with this context information that it's coming from the HTML content of this very page, right? I hope you recognize this page. It's the one of the JEPs, right? This is JEP 485, and this one is describing stream gatherers. So basically, what I'm doing is this. Like, let me maybe hit this because there is a timeout. To like prevent bots and so on. Generate one. So basically, I'm trying to grab the content, the visible content from the page, and I know which page that is, and then combined with this prompt, I'm giving it to LLM, saying, now, with this extra knowledge and what you already know or what you were trained on, give me the answer, right? As you can see, it takes some time to process it, and this is like indeed this what we see here. This is the just the content of the page, right? This is it, right? So I'm just I printed the output, and just to make sure I know, like we all know what I'm talking about. How do I? Oh, it started generating. Okay. Yeah, okay, so maybe let's switch. It says, okay, I'm trying to understand what stream gatherers are. See, they had this find, and now it knows it's this JEP. Yeah, this is the method, and so on. So this is this like thinking or reasoning phase, right? And after this, it will generate the answer. But you can already see it's like now it's talking reasonably about these four parts, right? Initializer, integrator, combiner, and finisher, and so on and so forth. So it looks like this time we might get the proper answer. So it's like with this, the policy, the HR policy of your company, right? We gave it the page, and now it's like, oh, I know this. Like using this page, I can give you a meaningful answer, right? This is what's happening basically right now. Yeah, let me stop it because else my fans will get loud, and this might be difficult for us to hear. Okay, let me switch to a proper window, which is this window. Yeah, so we found this right piece of data. We gave it to this context window, right? And then we get the proper answer, right, about stream gatherers. The thing is, if you paid attention, I explicitly knew and provided the URL, right? So I already knew where this data is. And the thing is, how to make the AI so it can search on its own and find the relevant data. That would be MCP. Or in case of RAG, how do we select it, on our own, so we can make sure it's the right data and so on. And we don't leak, any secrets, so we can like pre-process it here, like sanitize, purify, whatever, before we put it or share it with LLM, which, by the way, doesn't have to be the public one. You see, I'm running the one that's local. It's on my machine. So far, except from like fetching this data from the outer internet, so to say, I didn't pass it anything. I didn't share anything, outside, apart from streaming with you. So you see what was happening on my screen. So yeah, it's about the context. The context matters. The context is the king here, because if I say football, right? And I guess it's like Ukraine and like Poland, even Germany, it's the same. Football means this, right? Whereas if we say football in the US of A, football means this. So it's about selecting the right thing. It's about, finding the right context, the right piece of information. You can't give AI too little, because then, what's the point? It still doesn't have enough input to give you correct answer. But you can't also give it too much, because then you're like wasting tokens, resources, money, CO2 and everything. So the whole thing is about finding the right context. So now for a few moments, I'll be getting into that, right? How to get the right context. I guess, this language wasn't listed in the comments you've entered, but I think like every person in IT, every developer or software engineer has heard about this language, right? It's called SQL. And it's like we select stuff from databases, from relational databases, and more actually. So just by looking at this, let's say this is like our e-commerce, and we like the user typed something right in the search bar, which is the ultimate interface, right, in e-commerce. And based on this, we were able to create this query, manually or using ORM or whatever. So we're looking for where the content is like milk and the content is like chocolate. The thing is, can we say just based on this what the user was actually looking for? Was the user looking for milk chocolate or chocolate milk? In English, it matters because you are either looking for, I don't know, sweet bar. I assume milk chocolate is a sweet one. It's not like the dark one. Or was it looking for, I don't know, one of these fancy beverages like chocolate milk for cereal or something? See, and this, because like, then what are the other things, for example, you will show in your shop? Right? For example, when you're out of chocolate, you can show like milk chocolate. Let's say you have only 3 in your store. Then you can show like other kinds of chocolate. I don't know, the chocolate with nuts or dark chocolate, or I don't know, some other candy bars or sweets. Whereas if the user was asking for chocolate milk, you can show some beverage, right? Something else, I guess, like sweet, not sweet, maybe even water, right? But it's thing about to be a thing to drink. So how then make search more semantic, or like more aware of the context, so to say? Now I'm going to explain or show you the concept called vector search. And this is going to be like a crash course, very oversimplified. Please don't write your PhD thesis about like based on these slides, okay? But that should give us the rough understanding what's going on. So see, this is a vector. It has just one dimension, and let's say either the character is cartoon or cartoonish or realistic. So let's say this was from the Fabula movie, right? Star Wars, and this is from the Star Wars like animated series or cartoon or whatever. And then we can say that Princess Leia was -1 here, so she's here, and Darth Vader was here as 1. This is just one dimension, right? And we can go more dimensions. So we can say, for example, it's also human or machine. So as you can see, this droid is a realistic machine, hence it's here, right? Versus like Leia, I mean, she's here because she's realistic and she's human, and Darth Vader is here, right? And he's cartoonish, and he's like in between being human and machine. And I guess we all know why, right? Because of his like breathing problems and so many implants and so on. And then we can add more stuff, right, to our this simply 2-dimensional space, and we can like fine tune it. So see, we can add what's his name, Luke Skywalker, right? I'm not Star Wars. I'm not that much into Star Wars, right? And he's not as much human as Princess Leia. Why? Because he has artificial palm, right? So that makes him like human. Let's say being human at 0.8. And see, this is how we finally in our vector space start putting stuff where it belongs, right? And these are the vectors from the starting point. Basically, we get these coordinates, and we can also get these vectors from stuff locally, or not just locally. Sorry, from just like how it works in IT, or let me put it like this. So what I can do, again, I can hit my local Olama, and I can ask it, hey, generate me the embedding. So the vector representation is called embedding. That's the term. And we then say, this is the model. As you can see, it's embedding model. It's not the generative model. It's an embedding model. It's a model that when it's given a prompt, it's giving us basically, I mean, that's oversimplification, an array of numbers. These are usually floating numbers, and depending on like what's the similarity metric, and that's a cosine, dot product, L2 distance, or whatever. I mean, we can have like usually these are between like -1 and 1, okay, and these are like floating point numbers. Yeah, and the thing is, now when we ask for something else, because not only dogs are lazy, sometimes we, the programmers, are also lazy. See, this is the representation that for this very model was looking like this. Okay, because the thing is, how do I get the query, right? When I do this vector search, I will also need to translate my query. Or for example, when I want, this is, let's say, my document, I need to index it, store it in my vector search, in my vector store, then I also need to know where to put it. It's just now, instead of 2 dimensions like we saw in this chart, I will have, like, let's say 512 or 256 or 1000 or 4K or whatever. The thing is, if you pay a closer attention for this very model, you see the numbers are changing on all positions. So it's not that just when this sentence ends, only the few last numbers end. You know, for this model, the whole concept it's trying to generate embedding for is like placed in different places in this multi-dimensional space, but it's not for all models. Sorry, this is going to be a little plug, but I'm sort of like excited about this. Let me show this. Maybe there are models. For example, it's called. Oh, I don't have it open. Let me show it. It's called Gina V5 embeddings, like this thing. Yeah, Hugging Face. And this is like a new model. Like it has like 2 weeks ago, and I've learned there's this thing. The name could be maybe better. It's called Matryoshka representation learning. So basically, it means that this model will generate for us 1024 dimensions, right? But we can decide to store, for example, only 512 or like 128. And that, I mean, if we shrink its size, like we go for the prefix, we, of course, we're losing some precision, but then we can maybe this is like good enough. And what we can do is store fewer dimensions, right? Pay less for storage, for processing, and so on. But it's still okay. So then it's like some models allow this to happen, right? So it depends really on the model. This very model was changing all the numbers, basically. Do you recognize this scene? Which film is it from? Maybe I should stop for a few seconds so you have a chance to think, or pause this video if you don't know the scene in the film. 3, 2, 1. It's from the film or the movie called Matrix, right, from 1999. So it's there was this scene where Neo was shown how Matrix works, of course, and there was this concept of lady working in a red dress by the fountain, right? So it doesn't look anything like that, right? It's not a screenshot from or still frame from the actual film, but yeah, many of us, if not of us, recognize this. Right, that this is Matrix, and then this is it, right? So this is the this is the actual thing, let me put it this way, and this could be the vector representation. I really didn't find so far a simpler way to explain what vector embeddings are. So this is vector embedding, and this is what it represents, that thing, or vice versa. We want to have this captured in vector store, and this is the representation. This is the vector representation. This is the embedding. As you can see, it's just like numbers, basically. And how it works, for example, in Elasticsearch is a vector store based on Lucene. You can store so-called dense vectors if you want to look for it after the starting point. If you want to Google, it's like dense vector. Right, because there are also like other kinds of vectors, and this dense vector is basically like storing these numbers and then allowing to create nice queries to find the relevant pieces, the matching ones. And this is how this thing works, right? So we have this query and we have this vector representation, right? Like we had with this, for example, with this Olama call, and these are the vector representations I have in my vector store after indexing these things, because I can, fun fact, it's not only text. I can have images, I can have audio files, documents, and whatnot. There are some, these are called multimodal models. They can, for example, understand or create embeddings for text and images. right? So you can, for example, have vector representation of images and search for them using using text query, or vice versa, something like this. And let me just now show you how this thing can work, right? So with this stuff, let me go and run the encoder sh, and let's ask it like, what are stream gatherers, right? And see, this has hit my my local Olama, and this is the query I have, and this is the vector, the search vector, or the embedding, the vector representation I'm looking to I'm using to look for stuff. And you might be now wondering, okay, but where is the data right now? Because we need to have not only this vector representation, but also these vector representations stored in I mean, somewhere like database, vector store. In theory, you could also store them in file. That wouldn't be efficient, but yeah, I mean, technically doable. Yeah. So how did it happen? Let me show you. So I have used, I've run it before this talk because it takes some time. I have basically used a crawler. That's open web crawler from Elastic, and what it does basically, you give it like a bunch of parameters, and like start from this web page and then continue. Yeah. See, it like initialized in memory URL, query, and so on. The queue, sorry, and so on. And this was the starting point, right? OpenJDK.org, and of course I was I'm using Elasticsearch, like I run locally. Maybe I can even show you. It's not a mystery. This is how it looks like, right? I have it in my Docker desktop. It's called Elastic.local. If you want to, like, the sources are online, and if you want to replay what I'm doing, let me switch to browser again, and let's go. I'll just show you real quick. It's Elastic Start Local. That's the thing. You need to have the Docker of whatever kind, or Podman or something, and you just run basically this thing. Or this thing for Podman, right? And that will, fetch the latest images, or if you want to specify a version, right? And this is like, I'm not sure, like a premium license for a month or something, and that will go for like fallback to the basic one. I'm already using basic one, so I'm showing the open source like, or unpaid version, right? I'm not using the paid version here. For this thing. And what I have here, see this crawler, if you paid attention, or maybe I didn't show it, was storing these pages here to my index JEPs. And how they look like, let me show you them in Discover, because that also matters, right? How do we do this vector search? Let's open this JEP for, I don't know, 188, right? A nice one. Okay, this one. And apart from, so SQL databases have rows or tuples. In document store, we have documents. Okay, that's the wording. So and as you can see, these represent the HTML concept. So I have the headings, the body, and so on. Right. So when it was crawled, I didn't lie to you. See, it was like crawled just not that long ago, and so on. Like the title, the URL it's coming from. This is nice. For example, you keep the source of the knowledge that comes to you, so then you can verify, for example, what AI generated to you, right? So now we have this the data in my document store, and the question is, like, how do we end up with this vector embeddings, right? Because it's a model, and there are like different ways of doing this. One way I'll show you should be this. So basically, I have here a script here. Where is it? Or I don't have it. No, I should have it. Or maybe I've lost it. No, this one, document enricher. So basically what I do here, this is like the sort of like no. It's not sophisticated. It's not optimal solution, but it works. What I'm doing here is the following. I just go to this index, right? I grab all the documents, in batches, and then I process every document, and for its body, I'm generating vector representation. Right, and it's going to be in the other index, and this other index is called my index JEPs with embeddings. So now I have these embeddings or vector representation, right? Let's view these documents. Oops, I can't. Okay, I have like sorry, this I didn't look for. I don't know. Let me just show you here. See, it's just because I never updated just before the talk, right? And that now there's a problem. Anyway, what I can show you is this. I have not just body, but I have new fields. So I have the body chunks, right? Because when you have the whole body of a page or the whole book, you can't just create this vector representation in, let's say, 512 numbers, because you will lose a lot of the meaning. So what we have to do is so-called chunking. So we divide it into smaller pieces, right? And then for each piece, we generate vector embedding, which is here called as predicted value. Right. So this is how I've done it. I mean, if you use the commercial version, you can use semantic text. That's very nice field type. It will just do chunking for you. Here, I have to do it manually, and I divide it into passages. So see, basically, I go through my. This is the function called create passages. Pullman solution. Basically, I take the whole body of the page. I divide it into these passages, which are like just few sentences combined together, but no longer than, let's say, 400 characters or something like this, right? And I have many of them per each page. So this is how or when. How and when and where this vector representation happens. Okay, there's like no mystery here. Yeah, and with that in place, what I can do is this exactly this vector search, right? So let me run one more script, which should be this vector search, and let's see it verified that I connected to Elasticsearch and also my Ollama. Why? Because I need to first hit Ollama with my prompt or my query or question, right? Get the vector representation, and then using this vector representation, I can find and fetch the most relevant documents, basically. If I had, again, like commercial offering, I could deploy the models or use them from the cloud, then I wouldn't need that many things. But that shows you that it's possible without going or like when you want to just play with it for stuff, or you can go for a free trial for Elastic Cloud for I don't know 2 weeks or so. Let's just go here for what are stream. Sorry, I can't type apparently. Gatherers. Yep. And see, I got these hits. I was quite fast, I would say. See, so I have this JEP, right, and these two JEPs, which were previews, right, for Java 23, Java 22, and Java 24. And I would have I could show you everything. I just decided to show only the title, the URL, and the score. So how much it's matching, right, or relevant. Apparently, this equally relevant as far as I can tell, at least here. So this is how the vector search happens, right? So now we'll have these, these things. So the relevant documents based on our vector representation, and we're able to pass it to an LLM or GenAI or whatever, which is like this other model running in my local Ollama right here. A few things I have to say about these vectors, because you might get into traps or or stuff, right? See, if let's say this is our vector space, oversimplified, but I want to show you something. See here, somewhere, let's say Northern Germany and maybe Great Britain, it's very crowded or populated. The same here, like New Zealand. Here, for example, there's basically nothing here, right, in this vector space. So that wouldn't be the best model for our domain, because searching here is difficult, and here it's there's, or here in Alaska, right, there's like it's underused. So more or less we would want to have them like spread as evenly as possible. Okay, and you see this little triangle here, I hope, right? And it looks like this. And if you have flat surface, then all the angles have to sum up to 180 degrees, right? Whereas when we have a sphere, what you can have is a triangle that has, for example, 90 plus 90 plus 90, that's 270 degrees, right? And that's possible, when you have like a little model of a globe, or I don't know, basketball or football at home. You can easily check it, right? Create like three right angles, and together that make 270 degrees. That means another thing, that you cannot just, for example, create your vector embeddings using one model and then use another model to run or create the presentations of your queries, unless these models are compatible, right? They might be compatible. For example, you have one model for let's say twin models. One model can generate like embeddings for text. The other can generate embeddings for images, and then they can talk to each other. But you can't just say, oh, I have a like model that generates me 512 dimensions, so I can use whatever other model can give me 512 dimensions. It's not working like this. It's not just because I have the same number of dimensions I can use whatever. Okay. We need to read this, and also like it says in the embedding model specification, basically how they calculate what's close and what's not close, right? Like I said, it can be like the usual ones, cosine and dot product, but they can be more. That's not unheard of. Right. So let's get back here to this. Let's finish with this Star Wars, right? So this, let's say, are our embeddings or vector representations, and we have like Han Solo, and he's our query. So now, again, maybe I can like wait for a moment, and you can think, right, or pause the video if you're watching us later. Based on this query, what would be my top hit? 3, 2, 1. Okay, and this is it. So it's Princess Leia, right? Because Han Solo, for this representation, he's both as human and as realistic as Princess Leia. So she's the most relevant, I mean, we call them hits, okay? Like we have a hit or like a result, okay? But this would, if this was the whole response, right? We would like need to compare them, like which character is the most similar to Han Solo. Then of course, then it would be Luke Skywalker. I hope I'm not confusing the name. Then I guess it would be equally this droid and Obi-Wan Kenobi, and of course this animated Darth Vader is the least similar, right? Because it's like, you can see it's the opposite in our vector space. And now, like, it's oversimplified. It's just 2 dimensions, but let's say you need to do this thought experiment and imagine this happening in like 256 dimensions. And these are just numbers, right? And that's it. Yeah. So now with all this together, what we can do is we can finally run this RAG, right? So this is like the grand finale. Let me go for rag.sh. Right, and what this script will do is like it does what we did so far, like combined. So it will hit Olama with our prompt, get the vector representation, then use this vector representation to hit Elasticsearch, which acts as a vector store in our case, to get the most relevant results. Right, and these results will be passed as the context instead of this, the body that we used with or got using 0 in this generate 1 demo, and we'll pass it to the second model, which is the one that is able to generate the answer. So let me just run it. Yeah, we have like full connectivity, and let's ask what are stream gatherers. Okay, enter. See, it already got the answer. I mean, the search results, right? These are the same again. I mean, no wonder. And there's just one thing, right? And I will doing this in the meantime, because I'm not sure if I have any fresh dad jokes prepared. If you have any dad jokes, please share in the comment section. Okay. I'm some sort of like dad jokes aficionado or connoisseur. So let me know you're really good dad jokes. There's one dad joke I know from my friend married, and it goes like this: do you know why AI is so darn fast when it comes to generating source code? It's because it's using all its 12 fingers, right? Yes, I know it was bad. I'm sorry. Yeah, as you can see, okay, it's like my desktop machine, and it's already like it also uses its juice or computing power to broadcast and process the video and so on. But as you can see, it takes time, right? So this thing, like finding these results, like using vector search, was much faster. You can't hear the fonts, but the fonts like started like now. I can hear them. Okay, and so this vector search was already faster, and now I want you to get this or understand this. Vector search can be used was the cornerstone or foundation of other things. Like then we build on top of this like semantic search. So when you have this issue with like a milk chocolate or chocolate milk, right? You get this thing. Let me show you maybe in the meantime. Yeah, one more thing. Again, sorry, but that will be the last one. I guess let me use this. Let me switch to cloud because I have it in cloud. Oh boy, the fans are really getting really loud. So what I have here is like this Gina model, right? And it's the capability that I can create like embeddings of different sizes. So it's the same model, and I can choose just to store 1/4 of all dimensions. And then I created a pipeline that's kind of like think of it as insert trigger, for example, from the SQL world. And this is what I've been keeping. So the text in my inventory index that would be like a table in SQL database, and I have two fields, right? This is dense vector with that many dimensions, another dense vector that many dimensions. Both are using cosine in this case. And then after I index these things, under the hood, it also generates these two representations, and then I can use either this 256 representation, right, to get the fruit. Of what's in Polish stands for fruit, right? And as you can see, I get, because this model also understands multiple languages, multiple Ukrainian languages, right? So you can see it's like finds Spanish, cherries, right? Apple. What else? The Apfel, so that's German, right? Bananas, that's French, and even tomato is a fruit, right? Remember this. And I can also use this 1024 representation. See, and that also gives us results. So sometimes these are of different order, right? Here I'm looking for ovoce, which is plural, so maybe that's why. But also, maybe sometimes we want to have less dimensions. You want to keep, instead of floating numbers, just integers, for example, because these are like, or even single bytes or even single bits. That's called BBQ. If you really look into something like this, you can Google for BBQ. Right, let's see if and that's it, right? That's it. So you can just run these vector queries, and as you can see here, I'm using the paid version, so I don't have to do this round trip. Anyway, let's go. If it started to, okay, it's getting the answer. It started generating in the meantime. So it was like thinking. It's again the same part, right? So it's thinking. I'm trying to understand this concept of stream gatherers and so on and so forth, and then it started generating this answer, and the fans are down, so it finished, right? So it has this key concept that it's custom intermediate operations. Yes, it has this interface, initialize, the integrator, combine, and finisher. Yes, and so on, and it has built-in gatherers, and so all of that is true. So see, now we've built a proper RAG. It's not hallucinating. It gave us a proper answer. We were able to scrap data from in this case from the public documentation from JEPs, right? But this could be like your wiki page or your knowledge base, basically, or whatever. We created, we chunk this, right? Divide it into smaller pieces, created vector representations full of them, and then using this search, we were able to find stuff that's relevant. Why vector search and not some other kind of search? It's because, it's about, like, for example, typos. Good luck handling typos, right? Of course, you can go for like synonyms and like something like this, but that might be difficult. Or with some languages, it's difficult as well. For example, think about German, right? When you have Heckscheibenwaschanlage, and this is the rear window sprinkler, right? That works great in vector search, not necessarily in the like good old classic search. So that's why it's used here. Let me go back to the slides because we need to finish, right? Sooner or later. And then there's this big question, right? This is kind of like the thing that was in the very topic of this presentation. Should I always use RAG? Because what's actually this RAG? As you've seen, it's nothing more as this kind of like architectural pattern. It's not a design pattern, right? But as we have like design patterns, like composer, visitor, strategy, observer, whatnot, we also can have architectural patterns. That this is actually like an architectural pattern, right? You have your data, you create vector representations, and then you ask the same model or compatible model based on your question to find your relevant context window, and then pass it to LLM and then get the right answer, right? So it's just a pattern. Do you always need it, right? And I would say maybe not. And there are like situations, because like I have this feeling, I don't know about you folks, but like you start listening to radio, there's AI this, AI that, you I don't know, open a Twitter or a news page and there's AI this, AI that, so sometimes you're even scared to open the fridge because maybe AI is in the fridge, right? Like already somewhere on the shelves, between carrots and yogurts. I don't know. However, it can be very useful, right? When you have to process or find a relevant piece of data and process this piece of data and give you like short, concise answer. And you have to like first make sure that the data you're passing to this AI model is really what you can share. For example, it has no secrets, nothing like that. And some people say, like I told you, that it's like I can share everything I have. Then I mean, you have like quite little because if you can send everything to you AI, that means you have little, or you're like very, very rich person. Or the other thing is this thing, right? It's also speed. Sometimes you don't have to go for this generation phase. Sometimes this retrieval is more than you need, because see, this was fast. And let's say like so many of us answered that we program in Java. So I assume if you are a Java developer and you're just given this page, that's enough. I mean, you're able to just read it and understand it. You don't need AI to like process it and like rephrase it for you, like we did in this very example, right? So it's really like maybe it's not always needed. It really it really depends. This thing. Okay. And there's this other question, which is like getting more and more popular these days. What about MCP, right? There are two different things, and we kind of like comparing apples to peaches, right? Or something like this, because Retrieval-Augmented Generation is, like I said, to me, it looks like a architectural pattern, whereas MCP is a protocol. It's a standardized way of like things talking to each other, like agent to agent, or agents finding things, in knowledge bases, vector stores, calling tools like send email or something like this, right? Both help these LLMs to access external information, but they do it in fundamentally different ways. And now I don't want to scare you with this wall of text, but basically what RAGs do is they first retrieve this relevant pieces of data, should that be text or image or whatever, and then inject it into this model's prompt, like I have shown you, right? I extended this context window that was simple, like text concatenation, nothing fancy. Whereas MCP is just how these tools interact with each other. So if you, for example, have MCP enabled knowledge base, for example, then AI can find on its own the relevant thing, right? Well, only maybe slower than, for example, when we use vector search and so on. So that is like this thing. And which one to choose? It's like they're somewhat like different, right? So when we only need a model to read information, right, to generate answer, for example, or like generate whatever, and where the data is unstructured, right? That's why this vector search is like so freaking powerful here. If we have structured data, we can use something else, right? We don't have to go for vector search instantly. And it's also about this security risk. And we use MCP when we want to also perform actions, right? Like we have this live structured data. For example, we have observability data. And I don't know, you want to ask you to a question, hey, like what's happening? Do I have like all my Kubernetes nodes up and are they healthy and so on and so on? And that also like we can enforce strict security boundaries. Fun fact: there's also like something like this from Elastic. It's the cornerstone of a thing, of a concept called agent builder. Because now we can, for example, use MCP to build your own agent, and the agent will take control and get this stuff, right? Again, I should have like something. Yeah, it's that requires paid license. That's why it's cloud again. So see, I asked it a question: what do we have in our inventory? And these are these it says that we have like fruit, vehicles. That's auto. In German, right? And electronics. And it's like maybe interesting how it got there, right? And I made it intentionally a little bit confusing. So it's using so-called tools. MCP is using so-called tools. And in this very context, they translate to queries, which are written in ESQL. That's new, query language from Elasticsearch. See this ESQL. It looks like this. It's like a child of SQL and Bash, so to say, and it didn't find any results in this inventory index, right? Because I intentionally left it empty. So then it tried another attempt, another approach, and it got nothing. So then it was like, hey, maybe this index is empty, and we try another one, and it found because it's able to list all the indices. Right, so it identified the most relevant data source, right, and then it asked this inventory-gina index, and then it found 11 results, and we can see the price, like time, tokens, and so forth, and then we got the answer. And I can continue, and we can build our own ones. I mean, we can pump data, you can create these tools like special ones, and so on and so forth, right? So this is what MCP is and how it's different compared to what are differences compared to RAG. The thing is, you can also go for both. Nobody said it's like one or the other. You can go, you can choose them together. So we can use MCP as this retrieval layer. So I like for the very first one of the very first demos, I have used SEO to get this like stuff, right, to enhance my context. So I can also use MCP for this. So we have RAG, which is the pattern, and MCP, which is the protocol, and together they can form something that can be like labeled as MCP powered RAG, right? So we use MCP for RAG for retrieval. So right, when you say like I want to implement RAG, and someone tells you should go MCP, it's not exactly the same thing, because this is like a protocol versus pattern, right? Yeah, and then there is like, we almost at the end. This question I get this question asked a lot, and since like you can't ask this question live, we have only like text at least now. It's like, because this whole like talk is about the AI to a certain degree, people are asking like, will we be eliminated, or will we suffer? I mean, we developers, software engineers, by the AI. And I don't remember the person who said that, but the answer was more or less like this. Probably you won't lose your job to AI, but you might lose your job to the person who can use AI, right? So with this whole talk, I wanted to, in general, like not just describe you, show you the pattern, right? One of the possible usages of AI. But I wanted also to show you that it's like actually not that difficult to use, to start using it. See, I wrote it in Bash, right? So that means as long as your programming language and your technology stack allows you to make, HTTP queries, you can build RAG in this language as well, right? You can fit it into whatever you have in your I don't know, product offering, what your company is doing. Because some people say, oh, we can't have AI, we can't implement like RAG or whatever because we don't do Python. Because many people say it's the Python that you need to have, right, to start having AI features. And that's, I'm sorry, that's not true, right? And apparently, I mean, there's been like research recently and so on that Java is the best thing to use AI because it's the fastest, right? Or one of the fastest. It has like compilation, static typing, and so on and so on. So Python might be nice in this regard for demoing, for researchers, but not necessarily for the the usage when it comes to like handling a lot of data and like a lot of traffic, a lot of users, and so on and so on. So if you're not programming in Python and you want to say, I can't do AI because I don't do Python, this is not true, right? You can do AI from any programming language, trust me, as long as you're able to make at least network calls. That should be enough. And with like a little like housekeeping or announcements, if you have more questions, right? It's been like an hour and I can't show you everything. I mean, the ecosystem, the whole thing is like huge. If you have more questions, right, about the stuff I was presenting about the free offering, open source versions of from Elastic, you're more than welcome to hit our forum. It's a free one. It's called discuss.elastic.co, right? You can ask your questions there. If you're more of a Slacky person, you can join our community Slack. That's also an option, right? For example, we also run, if you're watching us, I don't know where from, or maybe later, we have many meetups, so we can join our meetup. There are like in-person ones, there are virtual ones or hybrid ones, so you can find them in this map as well. And you will find all these links here right at this page /community, or we can scan this QR code. You will get this Discuss, Slack, meetups, and so on. And there's one more thing. It's called, the abbreviation is BBL, which is also stands for Brown Bag Lunch. And this is basically a meeting. This could be like a person one or a virtual one. It's a free one. I run these around events, for example, when I travel to another city or something. Like basically, it's a like a private meetup during lunch break in your own company, like conference room of your not conference. Oh, but yeah, conference room. That's the term in English. Sorry. There's more details how it looks like terms and conditions and what to expect, what not to. Last thing, I would kindly ask you to provide some feedback, and not just for me, for every speaker at CoffeeJug, and also like for other communities. Because if you don't share what you think, was it useful? Was it not useful? Was it easy to follow and understand? Maybe too fast? Maybe you said like, oh, I had to watch you like 0.75 because you talked too fast. That's fair feedback as well, or something like this. Please share your feedback. You can use this form. It's an anonymous form. Like, I don't know who you are unless you introduce yourself, right? So scan this QR code or click this link or whatever. Just let me know how do you find this whole thing. I can also share this with organizers if you'd like to say something anonymously. I don't know. And with this, I would say this is it about this presentation, to RAG or not to RAG. Дуже дякую. And maybe we have some questions. Let me put my headphones on, so maybe we have some questions.
Yeah, hello, Piotr, again. Thank you for this presentation. Yeah, we have a couple of questions. First of them, how do we know what business data we have to retrieve for specific user request?
And now I would need to answer this as a proper consultant. It depends, right? But how do you tell good consultants from bad consultants? Good consultants also tell you it depends because, right? It's not fully obvious to me what we're talking about, MCP or RAG, right? With RAG, it's like we need to, this is, there's the whole concept or area, art or science or craft, whatever we call it, of retrieval. It's like in this slide, let me go back to this slide. It basically starts in here. Let me just go back. It takes time. I'm sorry. It goes back to here. First, you need to, if we go about to use vector search, right, you need to find the right model, right chunking strategy, right, the right search algorithm and parameters. Maybe you want to go for hybrid search because you want to go for like classic search and vector search combined and such stuff, right? I don't know. So this is not easy to answer in terms of RAG. In terms of MCP, you need to make sure that you, for example, your agent has the right MCP tools at its disposal. And if it takes time, this is like what what's available in Elasticstack, right? You can create your own tools, meaning your own queries. If you figure out that you as a human know better how to write a query to tell, so the AI can later on use it to extract relevant data, right? You can wrap it in a tool, right? Give it a description and so on. So then the AI can use it. So there's like a really like a lot of options, and it's like depends on kind of business data. If you have, for example, PDFs, you will use different chunking strategy. If these PDFs have a lot of charts and diagrams and images, you will need a model that can also sort of like create vector representation of these images and so on. So this is not easy question to answer because it really depends, right? We'll need to see the business data.
Thank you. And we have one more question from Julia. Could we compare vector representation of text content and image?
Same answer. It depends. Yeah, but like it's totally doable. I can point you. I know it's a shameless plug. Okay, I can point you to another talk given by me and by my friend Marit van Dijk. It's called Learning Model Java the Playful Way. That's the whole title. And in this talk, I'm showing and we're using a model that can do like this. It's called it's a kind of a multimodal model, right? So it can understand or create vector representations for images and books. Sorry, and text, right? I was thinking ahead. And then if you have a picture, for example, and on this picture you have like a book and let's say an apple on this book, right? And you process this these images, such images, and you store the vector representation in a vector store, like Elasticsearch, for example, but you can use something else, of course. And then you also have this query, and you use this model to create a vector representation of your query, which is like text, like ritual text, like apple or books or apple on books. You can use it to, I mean, this embedding from translated from this text query to search among the embeddings of the images, and vice versa. There's another talk, a great talk. It's Vector Search: The New Era. It's given by my colleague, a true hero of Elastic and DevRel, David Pilato, right? Vector search or semantic search the new era. Just look for new era. What he does there is he has indexed songs, okay, and what he does live on stage, he whistles to the microphone, like, but that's a song, that's actual song, and there's a vector representation of what he whistled, okay, and then just vector search gets him the most similar song. So it's like whatever you can turn into vector representation and whatever the model is able to compare things to, I mean, it will work. And then this is the nice part. You can use this, to create context search, to create semantic search, and so on. So the vector search is just like the cornerstone. And you can use it not only for RAG, but basically for whatever, right? Like in this e-commerce example. So what people are looking for, chocolate milk versus milk chocolate, you will show them the right things to buy, and you will have like satisfied customers and so on. So yeah, doable, but it requires proper model.
Fair enough. And we have last that joke from CoffeeJug. Probably Igor
Nice.
have some fun on the backstage. So, what do you call a fly with no wings? A walk. Igor, we really appreciate your joke. Thank you.
Yeah, it's a really nice dry dad joke. Yeah, sorry, I maybe I can like add one more. Do you know
Sure.
when a joke becomes a dad joke? When it's apparent.
Good
Yeah.
one. Good one. Good one,
Thank
I
you.
would say.
Thank you.
Okay, thank you, Piotr, for your presentation. Thank you, guys, that you joined us today. Wish you a good, safe night, and see you later.